Hi, I'm Roy, and I pace. And before I start this presentation, there are two notes that I wanted to make. One, I think this is literally going to be the first time I've ever been the least funny presenter in a day. It's an awkward and uncomfortable position for me, so hopefully you'll bear with me. The other one is I timed this talk for about 20 minutes. We're supposed to have 30, in the hopes that we'll have about 10 minutes of Q&A. So as you see things here, and you have questions about them, I have every expectation I'll be able to answer at least a few questions. So, I'm Roy. I work at inside engineering at Netflix. I'm here to talk about monitoring systems. So obviously what I want to actually start with is Joseph Campbell. Joseph Campbell was a mythologist, lecturer, writer, and in 1949 he came up with the idea of the hero's journey as what's been described as the monomyth. So the idea is that every myth out there is based on essentially some common elements. It's kind of like from a software engineering perspective, kind of like the pattern, like factory or bridge or whatever. And he proposed that basically all of those myths had some common elements. So it starts with an ordinary person who is just going about doing their own business. And at some point they receive some sort of call to action. And they might be relatively dubious about this call to action. They might be comfortable with their current life, or this call to action seems kind of silly. But eventually they take on the task and they embark on their journey. On their journey, they encounter a bunch of enemies and they vanquish them. They undergo some sort of terrible ordeal where they start questioning some of their choices. And eventually, they emerge from their ordeal successful and transformed and able to help their fellow human beings. I've gotten really good at searching the internet for pictures of my coulter for this presentation. So that's the end of the hero's journey, and that's actually the beginning of this talk. Because sometime around the beginning of 2013, we finished our hero's journey of building the next generation monitoring system for Netflix. It went into full production in our most busy region in Q1 of 2013. And that's where we started having some interesting challenges, because it turns out that if you build a system for real-time operational insight for a large, reasonably successful company, a system that's used both to know whether or not everything's working, but also to actually drive a bunch of automation like scale up and scale down, it's kind of important to know whether or not it works. And so it turns out that figuring out how to monitor monitoring systems mostly involves just, getting a bunch of turtles. So to talk a little about how we actually do this, I want to first disambiguate monitoring from alerting. For us, those are two very different functions. In fact, there are two completely different teams responsible for each of these. Monitoring, we think of as essentially sort of like specialized databases holding sort of like specialized kind of data. So monitoring systems are platforms that get a bunch of data in and make that data available for querying from other systems. Unopinionated is an important facet here, right? So they don't care, they don't have any opinions, there's no meaning to this data. Separately from that, however, alerting systems functionally basically output decisions and opinions. They may not be the right opinions or decisions. They quite often aren't, but we can talk about alert tuning in another time. But generally speaking, they take a bunch of data and they output opinions. So how do we figure out if this thing is actually on? So let's talk about alerting first, and let's talk a little about the alerting ecosystem at a very high level. Mostly involving rounded boxes, because much like Brian, rounded boxes make me comfortable, which is important when you're standing in front of 500 people. So we have an alerting cluster. The alerting cluster knows how to query our time series database, Atlas. And so basically a query that evaluates to true means that an alert is fired. A query that evaluates to false means that you're okay and you can continue sleeping. When an alert is in fact evaluated to be true, then we send the alert to an action service and tell the action service to do something about this. The action service can do a bunch of things. It can actually act on AWS to reboot an instance or terminate it or take it out of load balancer or, spend a bunch of money on, a new SG. Or we can send an email, or we can send a page, or a bunch of other things. Or we could actually send the alert into SQS, Amazon's simple queuing service. So that was sort of like the first version of this. We've now added the ability to have individual servers in our environment actually check alerts on themselves. There are some nice things about that we like a lot. One, it means that the latency of figuring out whether or not there's a problem in a given server goes down a lot. Instead of basically going through the whole publishing pipeline of our metrics, which I'll go into in a few minutes, you basically check on the local server, and so latency basically drops to nothing. It's also far more reliable, right? So if you're just checking for server conditions on the server, then you don't have to worry about the health of the overall sort of publishing pipeline for metrics. That's what our customers, Netflix engineers who have to actually operate their service for a living, like. From our perspective, every alert that is evaluated on an individual server is an alert that's not evaluated against Atlas. And given that Atlas can basically be thought of as a specialized database, we care deeply about the query load on Atlas. So this is good for everybody. The other thing that we now have actually is a stream processing system. Everybody needs one of these, or thinks they do. And you can actually define a job on the stream processing system that says, based on the ongoing sort of stream of events, you can actually fire an alert into the action service. And so figuring out whether or not this stuff works ends up being kind of relatively simple. Does everybody see the arrow sort of throbbing here? Thank you, Keynote, for animations. So basically, we have configured alerts on some long-running servers. And by the way, it's worth noting, it doesn't matter if you configure this kind of alert on one server or many, because all you need is just an ongoing stream. So the servers launch an ongoing stream of alerts against the action service. There's an alert configured here as well that sends alerts ongoingly to the action service and from the stream processing system. And then there is a checking server that basically checks for the ongoing existence of messages going to SQS and lets my team know when we start seeing one of these channels essentially not ongoingly sending alerts. One might ask, Roy, but what happens if the hot checker goes down? That'll probably never happen. So what happens is we actually have a cold checker. And the cold checker checks the hot checker. And one might ask, what happens if the cold checker goes down? The good news is that'll probably never happen either. But more realistically, the hot checker and the cold checker actually check each other. And that's how we know that alerting works. The other way we know alerting works is because probably, and we'll talk a little about volume, somebody's getting alerted at any given moment anyway. So let's talk about monitoring. And to talk about monitoring, let's start with a brief description of sort of like the overall sort of ecosystem of a, let's call it an Atlas deployment pod. So we have a published cluster into which metrics are sent at remarkably high volume. That published cluster sends metrics into what we call the 6-hour tier. We call it the 6-hour tier because this is the tier of servers that holds the last 6 hours of metrics for us, and we're not very imaginative when it comes to naming things. So the 6-hour tier then also flushes all metrics into S3. And there's a map reduce job that basically takes all the metrics in S3 and basically does a bunch of aggregation based on config parameters and sends those metrics into the 3-day tier. I'd like a volunteer to guess at what the 3-day tier does.
It stores it for 3 days.
Give this guy a reward. The audience participation part is not quite over yet. The MapReduce job also does basically different kinds of aggregation and sends them to the 18-day tier. Anybody want to tell me why the 18-day tier is named that way? No players, huh? Okay, good. So, and then there is basically a query cluster, and you can send queries into the query cluster, and it maps out those queries to the 6-hour, 3-day, and 18-day tier, and takes back the results and gives them to you in large chunks of data or potentially graphs. So let's call this an Atlas deployment group. So this is the box. Okay, so we currently run in a few production regions at AWS, and in any one of them, basically we have a bunch of servers who send their metrics into a proxy cluster. And that proxy cluster actually sends metrics into 2 deployment groups, one in US West 2, one in EU West 1. So basically all of our global metrics end up in 2 different regions, separated by a few thousand miles. And from our customers' perspective, and when I say our customers, I mean Netflix engineers who are operating, that's really all you need to know, because all of your queries and everything we do will end up going against one of these 2 deployment groups. So how do we know how well this works? Well, in a sort of feat of yo-dogging and sort of recursive engineering, we've actually deployed Atlas deployment groups in each region for our own use. And so all of our infrastructure, the proxy layer and the sort of customer visible deployment groups, send inside engineering private metrics, IEP is inside engineering private, we're not good at naming things, into these deployment groups where we actually do the monitoring. And you might ask, Roy, but how do you monitor the IEP deployment groups? Well, the good news is they're unlikely to go down. I'm surprised at the laughter because most of you don't actually see how we operate. It's almost as though you know what our daily life is like. And so it turns out that actually we have also built a critical stack which monitors the deployment group in the given region. It's worth noting, by the way, that for our own monitoring, all of the monitoring is happening in region. So we have opted to not deal with inter-region traffic for this really critical monitoring. And if your question is, how does a critical stack get monitored? The good news is, frankly, again, the IP deployment groups and the critical clusters monitor each other. And that works, and that's generally speaking how we know that things work, except that there's another way we know how things work, which is this. If you design a monitoring system with some important philosophical opinions, like for example, we should fail loud rather than quiet, and we should ongoingly strive to lower the time to detect for alerting. That essentially means that when your monitoring system has a sufficiently significant failure, you're going to find out about it. For example, this is a piece, this is the beginning of an email that was sent around like 9 a.m. or so on February 9th, 2017. It's sort of the beginning of a postmortem process we had from the last significant monitoring failure we've had. This morning, around 5:04 US Pacific, the active primary region hosting Atlas metrics data began experiencing issues, and a number of alerts were triggered across the board. So a significant enough failure will in fact trigger a whole lot of alerting in our system. This would be really, really terrible if we had significant monitoring failures on an ongoing basis. Thankfully, we don't. We typically see something like this happen, I don't know, every 18, 24 months, something like that. So we have so far basically decided that that's a reasonable trade-off for us. If at some point we start really, really pissing off our engineers, they'll let us know about it one way or another, and we'll figure out a better way to fix that. So that's operational monitoring. So let's talk a little about cost for a second. So the good news is I work at a company that basically tells engineers that generally speaking, cost doesn't really matter. It's not exactly true, but it's actually the third priority behind speed of innovation first and availability second. So if you're running some sort of small service, we don't want you to worry about cost. Worry about serving our members. By the way, any Netflix members here? Oh, awesome. By the way, I work for you, so you can basically tell me what to do. So, generally speaking, don't worry about cost. And that's true, except that, well, let's talk about metrics growth, because we essentially, the cost of our system scales as a function of metrics. So this is basically from around May of 2011 when we started counting. We were at the time storing about 2 million metrics, which seems, I don't know, to me, I think at the time that seemed a little high. But you can see that over the next, gosh, like year and a half, we went from 2 million to 75 million, which is like a 37.5 times increase. So here's the bad news. This is the graph for the first year and a half. And then that high point is this point. And you can see that basically in the 3 years since we went live with Atlas, we actually grew by 3 orders of magnitude. Pop quiz. Does anybody know which thought leader said this? Thank you. So we don't pay that much per metric, but when you have billions of metrics, it turns out that they kind of add up. And the reason you end up with billions of metrics is because unlike in the old days, I remember running NetSaint at home back before it was Nagios. In the old days, metrics were basically just some sort of vector of ASCII characters, right? But if you look at the Metrics 2.0 manifesto and most modern telemetry systems, I would argue, most people these days believe that metrics should actually be basically sort of an arbitrary key value pair, right? An arbitrary list of key value pairs. So for example, this is a metric in our environment. You have the name CPU, NF region, US East 1, NF zone, US East 1A, NF app API, NF cluster, etc. NF node, device operational name, Roku, is supplemental video false? By the way, I have no idea what these last two mean, on complete operations, etc. So if you think about metrics cardinality as basically being the multiplier of every tag time every tag value, you can see how you might have rapidly increasing metric counts. There are 2 kinds of rapidly increasing metric counts that we care about. The first one is what we think of as an oops. In our environment, every engineer basically figures out what metrics they want to send into our system. And so you might be tempted as an engineer, especially if you're debugging something in test, to add some metric tags that might be kind of useful to you. Like for example, hey, maybe I should log the source IP address of the request originator. And if you're at the edge of our system, so actual customers talk to you, it turns out that our customers come from a very wide variety of, IPv4 addresses. I don't mean to be bigoted here. This is just IPv4. IPv6 has like dozens more IP addresses. By the way, just to be clear, this is a true story, and I'll show you in a second. Another example of what might seem useful is, hey, I'm going to log the account ID for the account holder of this request. And we recently celebrated having 100 million members. It turns out that 100 million is like it's a big number. It's like 10 to the 9th, thereabouts. And, or you might want to log customer ID. Customer ID actually maps relatively closely. Basically, if you're multiple profiles, then each profile has a different customer ID. If you're only one profile, then the primary profile is the same, the customer ID is the same account ID, but basically, large number. And then the other fun stuff is people who want to know how long a request took might reasonably add a tag that says, hey, execution time. And log it in like milliseconds. And most requests time out within about 30 seconds, which turns out that you've got like 30,000 potential tag values. By the way, remember that graph earlier? This graph, this little spike here was when our, one of our edge systems started logging IP addresses as a factor of metrics. And we're like, oh my God, 1.2 billion metrics, that's huge. And thankfully we got them to cut it down for a while. So what do we do about this? Well, it turns out that we actually have pretty good monitoring for both the number of metrics being received by us, so you can see this being a diurnal pattern, and also the number of metrics in our actual data stores, and we can, anything in our environment that you can graph, you can easily alert on. So we can get alerted pretty easily. And then we send people nice little emails going, hey, we are seeing 100 million increase in Atlas metrics over the past day, with the most dramatic increases occurring within the individual whatever applications. This translates to a specific dollar amount increase in Atlas cost capacity, with a nice little link to this report that we've created that actually lets you basically look at any given aspect of your environment and see basically the increase. Like overall, we went from 38 million to 138 million, and then each of these apps grew by some sort of ridiculous amount. And then people do the reasonable thing and we go back to normalcy. But that's the acute problem. For longer term problems, we go back to, in fact, the same song by Depeche Mode. Most people don't remember that that song includes the phrase, the graph on the wall tells the story of it all, which is like, boy, monitoring, if there's ever, like, I don't know a better like pop song about monitoring than that song by Depeche Mode. And if you do, I don't know, tweet it and hashtag Monitorama or something. So what we did was we ended up spending some of our resources as a software engineering team actually building a system that lets us visualize metrics volume over a longer period. So this is about actually 6 months. And what we did was we figured that if we just gave people the tools to know how many metrics they're using and how much it costs, they would just magically do the right thing. Quick hands up, who would imagine that that would actually just naturally work? Yeah, the Netflix. Wait, you're at Netflix. How could you possibly raise your hand? So it turns out that if you just give people numbers, that doesn't really do much. So what we ended up doing was we work closely with the application teams responsible for the top 10 apps here. The good news is, frankly, the app teams for the top 10 apps today are probably about 90% identical to the app teams for the top 10 apps a year ago. And we basically don't worry about everybody else. And we tell them not to worry about it. So we work with these teams closely. We've gotten them to agree to try to not grow their metric count by a factor larger than any business KPI they care about. We don't even specify it. That's worked reasonably well for us. You can see that basically we were relatively flat for 2016, which was a remarkable achievement for us. And in fact, about a month or two ago, we worked with one of the teams to effect about a 700 million metric reduction, which in our world actually translates to real money. So those are the two aspects of this that I really wanted to talk about. I actually wanted to talk about a third, but I'm not going to spend too much time on that, which is around monitoring how people actually use our system for two purposes. One, from a product perspective, we think of this as a real product with about 1,200 customers, all of whom know where we sit. And we're interested in figuring out how they use the product so we can make it better. The other one is we think that we might be able to actually get meta signals about the health of our overall system if we can understand sort of like correlation of alert volumes, for example. So there's a bunch of new graphs that we've got, and we're working on this project. This is, for example, email. This is just alert emails over the last month or so. You can see that there was one day where we got up to about 25,000. So we're basically running a small-scale spam operation. Except that instead of telling you that there's a few $1 million reserved for you if you send us your social security number and bank routing number, we're just telling you that you've got a problem in your system. So there's a bunch of these things that we're working on. So this is, for example, breakup of alert volumes per group and per system. And this is something we're working on. And in fact, Swaroop, do you want to stand up for a second? This is Swaroop. Everybody say hi, Swaroop. Swaroop is working on this project, and last week we were talking about, hey, how can I get the most value out of Monitorama, he said, and I was like, well, what do you want to do at Monitorama, and why are you going? And he was like, I want to talk to other people who are interested in this field, and I was like, you know what? I can actually tell people, hey, everybody, meet Swaroop, and if you're interested in this field, find him. He'd love to talk to you. And that is the end of the presentation and the beginning of the questions. I've got about 6 minutes, so I'm happy to answer any questions. Meanwhile, by the way, inspired by Alice, hi Alice, I've put up a graph of the number of high urgency incidents since the beginning of the year from my team. we've had 23 incidents like that, actually 24, sorry, in the last 6 months or so. So, yes, well, so they're actionable. You'll notice mean time to action is between 3 minutes and 4 minutes. This is the stuff that wakes us up, and we tend to be relatively aggressive about that. But on any other note, what shall we talk about for the next 6 minutes before Will pulls me off? Yes?
Could you talk about the inputs that went into deciding in the periods you have for the metric storage, the 6 hour, 3 days, was it, and 18 days?
We basically looked at the...
Question, please?
Yes.
Thank you.
Sorry, did you say could I or should I? Or would he? The question was, how did we decide between 6 hours, 3 days, and 18 days? First of all, the 6 hour thing, originally we had no way to do any sort of metrics aggregation before it hits the first tier. And so the question was basically how long, and by the way, the first tier was also the most critical one. We think that most problems should be able to be solved via the 6 hour tier. And so it was like, how long does it need to, how big does it need to be in order for you to be able to solve most problems, one. How small can it be while helping you solve that? Because of course that's like a ton of, that's like thousands of servers. We hold all of this in memory. And then also, if you think about the MapReduce job, moving metrics into the 3-day tier and the 18-day tier, we've got to make sure that MapReduce job actually finishes. So the 6 hour tier allows that MapReduce job to actually fail once or twice and still go into the 3-day and 18-day tier. Nodes typically are still maintained within the 3-day tier, so you can actually see on a per node basis your metrics. But we think that given the average lifespan of nodes in our environment, which is shorter than 3 days, the 18-day tier actually drops node information for most of that. So it's an ongoing sort of like analysis of the kind of queries we have and balancing size and cost. Did I answer your question? Good. Yes? How many engineers does it take to operate this? Good question. It's hard to define operate, right? Because I don't actually have any operator people. I don't have any ops people, really. I have about an 18-person team of software engineers who also happen to operate this because, as Alice noted, if you build it, you really should monitor and operate it. It feels like the operational load is not that big. I would say that I could probably get away with 1 or 2 ops people, except that if I separated dev and ops people, I think terrible things might happen. Am I out of time?
I mean, if you don't mind giving it back, I take it.
Okay, tell you what, I'll take one more question and then I'll give you the rest of the time back. Who has a great question that they're going to be dismayed if I don't get to answer? High stakes. Who has a terrible, silly question that they'd like to answer? Bridget.
No way, because Alice had her hand up and I want to hear her question.
Very well. Alice.
Is there a certain television show or film on Netflix that causes more outages?
The question was, is there a certain television show or film at Netflix that causes more outages? I want to actually answer that in a more serious way. I've been at Netflix for about 8 years, which in like Roy time is, forever, and actually Netflix time is a long time. One of the things that I really appreciate actually is the sort of increasing maturity and stability of our system. When I joined Netflix, every time we had a new device launching, for example, the PlayStation 3, I remember this, we had a bunch of war rooms and we had a bunch of people pay close attention to graphs because every device launched could potentially take us down and cause problems. And then at some point, device launches became kind of normal and ordinary and we don't pay attention to them anymore. And then at some point, we started releasing new original content, like for example, House of Cards or Luke Cage or whatever, though this was way before Luke Cage. And in the beginning, every new original series launched, every new season was like a big deal and we were nervous about it and there would be war rooms, which is a problem because we would launch at midnight and there'd be people sort of like sitting there with food to watch graphs to make sure everything was fine. And then at some point, like original content became kind of like a non-issue. We release it and the people who care about the content watch it, but from an availability perspective, there's no impact. And then we started launching in different countries. We went into like, Canada, which is practically a different country, and we went into Latin America, and each one of those was like a really big deal. I mean, I remember we going to Latin America, and it was over Labor Day weekend, And we had a bunch of people there, and I actually like brought in like a smoker and did a bunch of ribs. And then like we went into the UK, and that was a big deal. And then, you know, every new country ended up not being a big deal. We are at the point today where basically I would argue that other than the global launch in the beginning of 2016, which was like, let's go into 200 new countries, thank you. None of that stuff ends up having a material availability impact. None of that stuff is something we worry about. And none of that stuff is something that we, generally speaking, pay attention to, except for like the business people who care about that. So the good news is, no. Watch all you want. You're not going to take us down. Thanks for your time. I'm happy to answer questions later. Catch me around.